When installing electrical conduit, specifically RNC or rigid non-metallic conduit, for an outdoor kitchen, understanding the National Electrical Code's requirements for burial depth is critical. Table 300.5 of the NEC provides minimum cover requirements for underground conductors and cables. The question is whether the conduit run falls under column 3 or column 4 of this table. Column 3 typically addresses situations where the wiring is installed under a building or concrete slab that is at least 4 inches thick and extends beyond the underground installation. Column 4 generally applies to all other locations. The determining factor for an outdoor kitchen installation with RNC conduit, even if a portion of the conduit is under a 6-inch slab, is the overall protection offered. Since all circuits are GFCI protected and a portion of the conduit run is not under the slab, column 4 applies. This means that the minimum cover requirement for RNC conduit under driveways and parking areas of dwelling units is 18 inches, and in other locations it is 12 inches, referencing the 2023 version of the NEC. Without GFCI protection, the required depth would be more. The specific edition of the NEC adopted by the local jurisdiction is the governing regulation. Always consult local amendments as they can modify the NEC requirements. GFCI protection significantly enhances safety in outdoor installations. A GFCI, or ground fault circuit interrupter, is a device that monitors the current flowing into and out of a circuit. If it detects an imbalance, indicating a ground fault, it quickly interrupts the power supply, preventing electrical shock. This is especially important in outdoor environments where moisture and contact with the ground increase the risk of electrical hazards. The NEC mandates GFCI protection for various outdoor outlets and equipment to ensure safety. The installation process for RNC conduit involves several key steps. Firstly, planning the route is essential, considering obstacles such as trees, landscaping, and other utilities. Secondly, digging the trench to the appropriate depth, as determined by NEC Table 300.5, is needed. Thirdly, assembling the conduit run, using appropriate fittings and connectors, is necessary. RNC conduit is joined using solvent cement, creating a watertight seal. Fourthly, pulling the conductors through the conduit, ensuring that they are properly sized for the intended load, is performed. Fifthly, backfilling the trench, carefully compacting the soil to avoid damaging the conduit, is completed. Finally, connecting the wiring to the electrical panel and the outlets or equipment, ensuring all connections are secure and properly grounded, is vital. Proper grounding is a critical safety measure in any electrical installation. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device, such as a circuit breaker, to trip and to energize the circuit. This prevents dangerous voltage from appearing on metal parts of equipment, reducing the risk of electrical shock. The grounding system consists of a grounding electrode, such as a ground rod or ground plate, connected to the electrical panel and to the grounding conductors in the branch circuits. The size of the grounding conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. In addition to grounding, bonding is also essential for electrical safety. Bonding involves connecting all metal parts of the electrical system together to create a common electrical potential. This prevents voltage differences from occurring between different metal parts, reducing the risk of electrical shock. Bonding is typically achieved by connecting metal conduit, metal enclosures, and metal equipment to the grounding system. The bonding conductors must be sized according to NEC Table 250.102. When working with electrical systems, it is crucial to follow all applicable safety precautions. Firstly, always to energize the circuit before working on it. Secondly, use appropriate personal protective equipment, such as rubber gloves and safety glasses. Thirdly, inspect all tools and equipment before use to ensure they are in good working condition. Fourthly, never work in wet or damp conditions. Fifthly, if unsure about any aspect of the installation, consult with a qualified electrician. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. It is essential for anyone working with electrical systems to be familiar with the NEC requirements. In addition to Table 300.5, other relevant sections of the NEC for outdoor kitchen installations include Article 210, which covers branch circuits, Article 225, which covers outside branch circuits and feeders, Article 250, which covers grounding and bonding, Article 310, which covers conductors for general wiring, and Article 352, which covers RNC conduit. These articles provide detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of the electrical installation. When selecting conductors for an outdoor kitchen installation, it is important to consider the ampacity of the conductors, which is the maximum current they can safely carry. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature. NEC Table 310.16 provides ampacity ratings for various conductors. It is also important to consider the voltage drop in the conductors, which is the decrease in voltage from the source to the load. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The size of the conductors can be increased to reduce voltage drop. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. An overload occurs when the current in a circuit exceeds the ampacity of the conductors. A short circuit occurs when there is an unintended connection between two conductors. Overcurrent protection devices are designed to trip and de-energize the circuit when an overload or short circuit occurs, preventing damage to the wiring and equipment. The size of the overcurrent protection device must be matched to the ampacity of the conductors being protected, as specified in NEC Table 240.4. When installing electrical outlets in an outdoor kitchen, it is important to use weatherproof outlets that are designed to withstand exposure to the elements. Weatherproof outlets have covers that protect the receptacles from rain, snow, and other moisture. The NEC requires that all outdoor outlets be GFCI protected. In addition to outlets, other electrical equipment in an outdoor kitchen, such as lighting fixtures and appliances, must also be suitable for outdoor use. This equipment must be rated for wet locations and must be protected from the elements. When installing RNC conduit, it is important to use the proper fittings and connectors. RNC conduit is joined using solvent cement, which creates a watertight seal. The fittings and connectors must be listed for use with RNC conduit. It is also important to properly support the conduit to prevent it from sagging or becoming damaged. Conduit support should be installed at intervals specified in the NEC. When bearing RNC conduit, it is important to avoid sharp bends and obstructions. Sharp bends can make it difficult to pull conductors through the conduit. Obstructions can damage the conduit or prevent it from being properly buried. The trench should be free of rocks, roots, and other debris. The conduit should be buried at a consistent depth to provide uniform support. When backfilling the trench, it is important to carefully compact the soil to avoid damaging the conduit. The soil should be compacted in layers to ensure that it is evenly distributed. The trench should be backfilled to the original grade level. After the electrical installation is complete, it is important to inspect it to ensure that it is safe and compliant with the NEC. The inspection should be performed by a qualified electrician or electrical inspector. The inspection should include a visual examination of the wiring, conduit, and equipment, as well as electrical tests to verify proper grounding, bonding, and overcurrent protection. Any deficiencies identified during the inspection should be corrected before the electrical system is put into service. Proper electrical installation is essential for safety and reliability. By following the NEC requirements and best practices, you can ensure that your outdoor kitchen electrical system is safe, efficient, and compliant with all applicable regulations. Remember to always consult with a qualified electrician if you have any questions or concerns about your electrical installation. Consider that while this information provides a general overview, specific local codes and regulations always take precedence. Consulting with a local licensed electrician is always recommended to ensure compliance and safety. They can assess the specific site conditions and requirements of the outdoor kitchen project.